When we have a set of parametric equations, we would oftentimes like to have a graph of those parametric equations. And one way to do that is to find the rectangular equation that is related to the parametric equations and sketch the graph there, and then decide on orientation and any restrictions that may occur on the graph. So here we are asked to find the rectangular equation and sketch the graph. X equals t minus 1 and y equals t divided by t minus 1. So to find the rectangular equation, we often eliminate the parameter, which usually boils down to solving one of the equations for the parameter and then substituting into the other equation. So notice here we could say that x plus 1 is equal to t. And if we use that information to substitute in for t, then we can obtain the rectangular equation. Y is equal to x plus 1 divided by x plus 1 minus 1. So y is equal to x plus 1 divided by x. Y is equal to x divided by x plus 1 divided by x. Finally, y is equal to 1 plus 1 over x. This equation is our so-called square hyperbola, and it is shifted up 1 unit. So we know what that looks like. If we shift this thing up, we get a horizontal asymptote, y equals 1. The graph looks like that, and then the graph also looks like that. Has two parts there. Notice at the beginning, when we look at the two parametric equations, we quickly see that the equation for y creates a restriction. Here, t cannot be equal to 1. Well, if t is not equal to 1, that means that x can't be 0. And we can actually see that from the rectangular equation below. X can't be equal to 0, or we'd be dividing by 0. So those are restrictions. Now, if we wanted to figure out the orientation for this graph, we're going to need some points. And the points need to be related to values of t. So we pick t's that are smaller, and then they move to larger t's. So if, for instance, t is equal to 0, well, remember our equations, x is equal to t minus 1, and y is equal to t divided by t minus 1. So, if t is equal to 0, then x is equal to 0 minus 1, which is negative 1, and y is equal to 0 divided by 0 minus 1, which is 0. So we get a point, negative 1, 0. If t is equal to negative 1, then x is equal to negative 1 minus 1, which is negative 2. Y is equal to negative 1 divided by negative 1 minus 1, which is negative 1 over negative 2, positive 1 half. So again, we get a second point, negative 2 and positive 1 half. So let's put these two on our graph. Negative 1, 0. and negative 2, 1/2. Now, remembering that in order to get orientation, we move from smaller t to larger t. So then the negative 1 would be the smaller t. That's where we get the point negative 2 comma 1/2. And then we're going to move to the larger t, which is t equals 0, which gives us the point negative 1, 0. So for this portion of the graph, and this graph's a little cluttered, so let me use a different color to indicate the orientation. We get orientation in this direction. For the other portion of the graph, we need to pick some different values for t, maybe some even larger values for t. So suppose here now that t is equal to 2, then x is equal to 2 minus 1, which is 1. Y is equal to 2 divided by 2 minus 1, which is 2. So we get a further point 1, 2. If t is equal to 3, say, then x is equal to 3 minus 1, which is 2. Remember, our equation for x is x equals t minus 1. So if t is 3, we get 3 minus 1. Y is equal to 3 divided by 3 minus 1, which is 3/2. So we get the point 2 on the 3/2. We put these 2 points on our graph. So 1 comma 2 is here. And 2 comma 3/2 is here. Again, we indicate the orientation from smaller t to larger t. The smaller t gave us the 1 comma 2. That was where t is equal to 2. The larger t is t equals 3, which gives us the point 2, 3/2. So again, using a different color for this graph for orientation, we're moving down the graph in that direction. So here we have a graph. It's a plane curve with orientation, which is defined by the parametric equations x equals t minus 1, y equals t over t minus 1.